Hi, Dylan.
Hi, Professor Popovich.
This is not going to, I've only got 13 slides. It's not going to take that long.
All right. I have a quick question.
Sure, I'm here.
I know it's been a lot this week, but have you had a chance to regrade my standardization of a hydroxide lab?
Are you talking about the regrade it? Okay.
I had transposed two of the numbers.
I'll be honest, I don't know.
Okay.
Let me, what grade did you have?
You gave me a 0 for it.
Okay. And that was the results?
Yes.
Results for standardization of a base, right?
I think so. Let me get on my SPC real quick.
1 second. Got it.
You got it? All right.
Okay. Right, okay. Apparently not, Dylan.
No, okay.
Okay, I will
Thank you.
I will get to that. I will get to it. Okay, I got 4 of us in here. Are we all doing okay? Jasmina, Vanessa, we doing okay?
Yeah.
Yeah.
Beachy came wonderful. Just happy to be here. Okay. Dylan, Sigfigs.
For the base lab?
Yep.
Okay.
Okay. I don't know what you're doing here, Dylan. To get the total moles of H plus.
Hold on, let me pull it out real quick.
Guys, I'm just sitting here waiting for people to get on here. Just waiting for people to get on. I don't know what you did for part C.
Let me look at it.
Also, Dylan, I'm not understanding what you're doing for question 2, part B. You're not putting the numbers in. If you don't put the numbers in, I can't. Okay, those are the 2 things. I just updated it. Question 1, Dylan. Question 1, part C, I don't know what you did. And question 2, part B, I don't know what you did.
Okay.
Explain it to me, and then we can go on from there. How's it going, ladies and gentlemen? We good?
Going well. Thank you.
Good. Okay. How many people do I have in here? People. I got 6 of you. They're going to be surprised. This is not easy to understand. So we've seen the screen.
Yes, sir.
Yeah.
We're seeing the screen? Okay. First half of this is not that difficult. Okay? The main thing you need to understand about the first half of it is you're using, I think the lab itself said potassium sulfate or something like that, sodium carbonate, something oxalate, and potassium iodate. What you have to understand that these are the solutions. These are your test solutions. Your knowns are going to be your barium, strontium, calcium, and magnesium. Okay? Do you understand that? You have no idea what I'm talking about, do you? What you are doing is you're taking 4 of the alkaline earth metals: magnesium, strontium, barium, and calcium. Okay? You're reacting known materials. You're reacting magnesium with sulfate. You're reacting magnesium with carbonate, magnesium with oxalate, and magnesium with iodate. You're doing the same thing with strontium. You're reacting it with each one of these. And you're trying to determine whether or not you get a precipitate. Basically, a precipitate is indicated by getting a milky color solution when you mix the 2 solutions up. So what you do is you put into a, it's like a little dish with 4 little depressions in it. Into the first dish, the first depression, you put SO4. Into the second depression, you put CO3. Third one, C2O4. The fourth one, IO3. And then you add an equal amount of magnesium to each one of these 4 depressions. If you see a solid forming or an opaqueness to the solution, that means you have a precipitate. And that's all we're determining right now, is we're determining precipitates. So after we do magnesium, you're going to do calcium. You're going to react it with all 4 of these. Then you're going to react strontium with all 4 of these. Then you're going to react barium with all 4 of these. Do we have that understanding down?
Yes.
So what happens? What happens is magnesium may not react with the first 3, but the 4th one, it will give you a milky white precipitate. So you mark it, no reaction, no reaction, no reaction, precipitate. The calcium may give you a precipitate with the first 2, no reaction with the 3rd, and a precipitate in the 4th. Strontium may give you no reaction, precipitate, no reaction, precipitate. And the last one, the barium, may give you precipitate, 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 precipitate. Now what you do is you get 4 new depressions. Into each one of those 4, you're at SO4, CO3, oxalate, and iodate. And you put your unknown in there. And you try and match your unknown to the pattern that formed with one of your knowns. Does that seem to make sense to you guys? Let's talk about a real fake example. I have AH, which is doctorium. I reacted doctorium with SO4. I got a clear solution. I reacted doctorium with CO3, got no reaction, clear solutions. I reacted with doctorium with C2O4, no reaction, but with my iodate, I got a milky solution. For my GER, my mean dogium, for my GER, I got a precipitate with SO4. I got a milky solution with CO3. I got no reaction with iodate, and I got a milky solution with IO3. That meant precipitate for the sulfate, carbonate, and my iodate. For my UG, my disgustium, I got no reaction with SO4. I got a milky solution with CO3, no reaction with C2O4, and I got a milky solution for IO3. For my Y, questionium, I got a precipitate with SO4, precipitate with CO3, precipitate with C2O4, and a precipitate with IO3. So I did all that preliminary work with all of my known materials. Then I came up with my unknown. My unknown didn't react with with SO4, CO3, C2O4, but it did react with IO3. So what pattern matches my unknown?
It would be, all right, doctorium.
Doctorium, you know, tongue compressor, doctorium.
Yeah.
It's lost on you. It's lost on you guys. So yeah.
I thought it was.
So guys, so yeah, you're trying to match. You're going to react your unknown with the same solutions you react all of your knowns with. Whatever pattern you get that matches one of your knowns, that is what your cation is. You've identified your alkaline earth metal. Anybody have a problem with this? Are we good with it?
Yes, sir.
Anybody have any questions about this? I'm hearing crickets, so I'm going on. All right. You guys have done these reactions. You have done oxidation reactions, oxidation reduction reactions before. I know you have because you've been exposed to single replacement reactions. That's what oxidation reduction reactions are. You can remember this. You can remember which one is which by either Leo goes GER or oil rig. Loss of electrons, Leo, loss of electrons is oxidation. Leo goes GER. Gain of electrons is reduction. Or oil rig, oxidation is loss of electrons, reduction is gain of electrons. I don't care which one you use, just use one. I stole them both. Now, if we react a halide, halide means one of the elements that's in the next to the last column. If we react a halide, which means it has a -1 charge, with a halogen, which means the diatomic molecule, and we get a reaction, what will happen is the electrons that are on the halide, the electrons that are on the ion, get transferred to the diatomic molecule. It splits the diatomic molecule up, and it makes that diatomic molecule have a negative charge. So we have two of the atoms, each of them have negative charges, and lo and behold, when the bromine in this instance gives up its electrons, it gets formed back to be Br2. So our half reactions, Br minus goes to Br2 plus 2 electrons. The Br minus lost electrons. That was reduction. the Cl2 gained 2 electrons to become 2 Cl minuses. So the Cl2 gained the electrons. That is oxidation. So that's what we're doing in the second half here. So to determine which halide is present, what we are going to do is we're going to react known materials that are in water. And then we are going to add the hexanes. Hexanes do not mix with water. What you have to understand is only the halogen, only the diatomic molecule gets extracted into the hexanes. And when it gets extracted into the hexanes, it changes the hexanes to a different color. We are only looking for the color that's in the hexanes. So we have the basic ground rules now. We're reacting a halide with a halogen. Both the halide and the halogen are in water. We're mixing them around, reacting them possibly. Then we're adding the hexanes. Hexanes do not mix with water. I get 2 layers. Only the halogen, only the diatomic molecule gets extracted into the hexanes. And when it does, it carries a color along with it. We're only looking for the color that's in the hexanes. So let's talk. We have Br minus and Cl2. Do we expect a reaction? Jasmina. Jasmina.
Hi.
Br minus and Cl2. Is Cl more electronegative than Br?
I think so.
Yes, it is. It's more electronegative than Br. So if it's more electronegative, is it going to want the negative charge more than Br will?
Yes.
So do you expect this to react to make Cl minus and Br2?
Yes.
Thank you, Dominica, for popping up. Dominica.
Yes.
Hi there.
Hi.
I have Cl minus and I2. Is Cl more electronegative than I2?
Yes, it is.
So is the I2 going to be powerful enough to steal the electrons away from the Cl minus?
No.
So do we expect a reaction?
No.
We're going good here, guys. We were going good. All right. Now, we have some chemicals. We have As2, aconite, which is a foolish element. If we have As2 and we have hexanes, it extracts into hexanes, giving a chartreuse color. If we have Bf2, B-fine, a meaty element, Bf2 will extract into hexanes, and I get a periwinkle color. If I have An2, alienine, a foreign element, that will extract into hexanes, making a carnation color. So As2, chartreuse, Bf2, periwinkle, An2, carnation. I had fun with this one, guys. Understand, As2, Bf2, and An2 are the only species that give colors. As minus, Bf minus, and An minus do not give colors. You have to understand, the more active element is ionic, whether it begins ionic and stays ionic, or whether it goes from a neutral molecule and reacts to become ionic. The more active element, the one that has the bigger electronegativity, that one is going to end up being ionic. We're going to be mixing the ion with the neutral color compound to see which one is more active. I mix An minus with BF2, and I get a periwinkle color. Somebody tell me what the periwinkle color indicates. What do I have as my final product that got extracted into the hexanes?
The BF2.
The BF2. So I mixed An minus and BF2 and got a periwinkle. Therefore, I know that BF2 got extracted into the hexanes. Did I have a reaction?
No, you didn't.
I did not. So, since An minus stayed ionic, Khalil, which one is more active, An minus or BF?
An minus.
An minus is more active than BF2. Sorry. Couldn't resist the pepper in the salad. All right. Now, I mix BF minus with AS2, and I get a periwinkle color. What is my final species? Is it AS2, BF2, or AN2?
It'd be BF2.
BF2. Did I have a reaction?
Yes. Yes, you did.
So, is AS more active than BF? Which
Yes,
one
it would
ended
be.
up ionic? Absolutely.
Because AS ends up ionic.
AS ends up ionic. I know this because I got the periwinkle color, which indicated that the BF minus got changed into BF2. That also meant that the AS changed into AS minus. So my AS is more active than my BF. Last one, Khalil, you are not allowed to answer this. I mix An minus with AS2, and I get a carnation color. What species does carnation indicate? No, not you either. You understand what's going on. I want somebody else.
Is it AN?
I don't want Dominica or who the hell was just there? Khalil. Dominica, Khalil don't understand this. Vanessa, give me the answer.
Is it AN2?
Which one? Look at these. Look at these numbers. Or look at numbers. Look at the thing down below, Vanessa.
Oh, sorry. It's the alienine.
Okay. So, did I have a reaction? Did I
Yes.
make AN2?
Yes.
I made AN2, which meant that my AS, did it get converted to AS minus?
Yes, because yeah.
So I got AS minus. Does that mean my AS is more active than my AN?
Yeah.
All right, so if I pull all that information together, my activity series, my AS was more active than my AN. I know this because this reaction went. So AS is more active than AN. I also know that AS is more active than BF because I got a periwinkle for this one. So I know that AS is great, AS is the most active. Then when I compare AN with BF2, the AN minus didn't change. So the AN minus is more active than my BF. So if I pull all that information together, I have an activity series AS is greater than AN, which is greater than BF. Does that make sense to you guys?
Yep.
All right. Now, if I did my reactions and I mix BF minus with BF2, I got a periwinkle color. I mix BF minus with AS2, I get a periwinkle color. I mix BF minus with SP2, I get a periwinkle color. AS minus with BF2, I got a periwinkle. AS minus with AS2, chartreuse. AS minus with SP2, I got carnation. SP minus, periwinkle with BF2, carnation with AS2, carnation with SP2. So my unknown with BF2 gave me a periwinkle color. With AS2 gave me a chartreuse. With SP2 gave me a carnation. Tell me which one matches up with my unknown results.
AS minus.
AS minus. So if I was going to combine them, what happens in this particular experiment? I give you one solution. The solution has a salt in it. The cation is the alkaline earth metal that you solved for earlier. The cation is the halogen or the halide that you just solved for. Right now, you got AS minus is your anion, and got to go all the way back to the top. And my AH is my cation. So my unknown would be AH, and I forgot what it was already. AH, AS subscript 2. And I know it's a 2 because the halides have always a -1 charge, and the alkaline earths always have a +2 charge. Do we have an understanding as to what we're doing with this experiment?
Yep.
Okay. Now, you may wonder why I went through all that other happy horse shit. That's because in the post lab, you're going to get asked questions like I just went through and logically defined for you. The post lab is not easy. Other thing, this is an important note. The results section is going to ask you what your alkaline earth ion was and what your halide is. And it's also going to ask you to describe how you determined your answer. I want specific results. For example, you could say, my unknown precipitated with carbonate and iodate and did not precipitate with sulfate or oxalate. This matched my known Therefore, I know that my alkaline earth metal was My unknown halogen extracted purple into hexanes when treated with Cl2, Br2, and I2. This matched my known acinine. Therefore, I know that my unknown is acinide. You understanding what I want for that second description? I want specific observations.
Did you want this as our not calculations, but the summary at the end of our lab notebook?
No, you don't need to do that.
This is just for the results quiz thing on my courses.
Yes, there's not going to be a calculation section for this lab notebook.
I wasn't sure if you wanted us to write this in our lab notebook.
No,
the conclusion. That's what I'm trying to say.
You don't need to include that in the conclusion, in the calculation section.
Okay.
And basically, for the errors, the only thing I can really think of for this is cross-contamination. The known samples got contaminated. You have
Okay.
no control over that. Okay?
Thank you.
Thank you.
Anything else, guys?
I had some questions about the last lab that we did with the triation of the antacid.
Okay.
Mainly because after I did
I
my
don't think I graded
numbers,
that yet, did I? Did I grade that?
I don't think so. No, you didn't.
Okay, it'll get graded tomorrow. Okay,
Okay.
Kamil, let me try and find grade attempt. Okay. Specifically, are you asking about yours?
Yeah, because I did the first trial and then I got one number, and then I did the second one, and the percentage for the calcium carbonate I got was
Way
pretty
off?
widely off. Yeah, pretty widely off. And
Let me,
it was probably
I
something
think-
I did, but
I think when I looked at the data, I haven't done this yet, so I don't really know. I thought when I looked at the data that I thought the data was widely off.
My two percentages were very different as well.
It may be that he was just trying to simulate. He may have been just trying to simulate real student data, or he may have grabbed somebody's data.
Mine were only like 7% apart.
I would too. I got
7% is still a whole bunch.
the two percentages at the very end.
Yeah, I got 55 and like 60.
Okay.
Yeah,
All
mine
right.
were only 2% apart.
All right. Somebody have the base was 0.09 what? Anybody remember? Anybody have that?
the molarity for the NaOH,
Yes. 0.09
that
what?
was 0.9917 molarity.
That sounds right. Okay. So what I'm doing to solve this, I'm getting first all right. What we have to do to solve this problem is you have to realize that there are two sources of base, one source of acid. So the total moles of acid are going to be used. Some of them titrated the sodium hydroxide, some of them titrated the calcium carbonate. All right, so the total number of moles of HCl is 19.76 minus 0.13. That gives me 0.01963 liters times 0.1001. This gives me a total of 0.001965. That's my HCl, total moles of HCl. Now, the base, I have 11.19 milliliters of base minus 2.26. That gives me 8.93 milliliters divided by 1,000 equals 0.00893 times 0.09917 equals 0.000886. So I subtract that from my HCl. This means I have 0.001079 moles of HCl that were used to titrate the CaCO2. But there are 2 moles of HCl for every 1 mole of calcium carbonate. So I've got to divide that by 2. This gives me 0.000540 moles of CaCO3. calcium's about 40. Carbon's 12, three oxygens are 48, so that's about 100. So this should be 0.0. Uh, 0.05395, which divided by 0.1011 gives me 53.4%. That sound familiar, guys?
Oh, that's not what I got. I think I did it wrong.
We'll see what happens, okay? Doing the other one. 3890 minus 19. Sorry. Okay, for the other one, I have 0.001916. And for the base, I got 18.21 minus 11.19 equals 60%. For the other one, I got 60%, so there's 7% difference. The two answers I got were 60.2%, and the other answer was 53.4%. So yes, there is a big discrepancy between the two numbers. I thought looking at the data that there would be. Is anybody still there?
Yeah.
Okay. Okay. That was Khalil. You were asking that question, correct?
Yeah, that's just what I wanted to know, because I got like an 80-something% when I did the numbers.
I don't know how you got that, Khalil. I'm gonna have to look at your numbers and try and figure something out, okay?
Got it. I mean, I got like I got around 60 for the second trial, but I was really confused how I got that for the first one.
I'll look at it, Khalil, okay?
Thank you, sir.
Anything else, guys? Okay, that's all I got for you. Sorry, I probably should have had, I spent the afternoon reading a history of Gettysburg, so I'm sorry, that's my bad. I should have had that done for you. Sorry.
That's fine.
No worries.
I will get it done. I will get it done tomorrow for sure. Okay, take care, guys. Seriously, if you have questions on this or the post lab, email me, give me a call. It is not easy. You have to logic it out. Okay, good luck.
Yes, sir. Thank you.
I will see you on next week. Some of you I will see on Tuesday. Remember, there's a test. Those of you that have me for lecture, there is a test.
All right, see you. Thanks.
Anybody have anything? If you
Thank
need,
you.
anybody need to talk to me afterwards?
I sent you an email with the errors that I found in the standard base lab.
Okay, so good enough. What's that mean to me, Dylan?
Oh, you had just told me that we had discuss the errors. So I was
okay.
saying why I got it wrong.
Okay, I'm gonna let it stand as is though, okay?
That's fine. I just wanted to make sure I'm doing it right.
Okay, I will check into it, all right? And I'll email you
thank you.
back. It may not be until tomorrow though.
That's fine. It can be next week.
All right.
Have
All
a good
right.
night.
You have a good night too.